Visible light is a small segment of the electromagnetic spectrum that the human eye can detect. It consists of a range of colors, each corresponding to a different wavelength of light. When white light, such as sunlight, passes through a prism, it disperses into its constituent colors: red, orange, yellow, green, blue, indigo, and violet. These colors together form the spectrum of visible light, with red having the longest wavelength and violet the shortest. The color of an object that we perceive depends on the wavelengths of light it reflects and absorbs. When light hits an object, certain wavelengths are absorbed by the object's surface, while others are reflected. The reflected wavelengths determine the color that we see. For example, a leaf appears green because it absorbs most wavelengths of light but reflects those in the green part of the spectrum. Conversely, an object that appears white reflects almost all wavelengths, while a black object absorbs most wavelengths and reflects very little, making it appear dark. Transparency and opacity of materials also depend on the wavelengths of light they absorb and transmit. A transparent material, like clear glass, allows most of the light that hits it to pass through without being absorbed, meaning it transmits light across the visible spectrum without significant absorption. This is why objects on the other side of clear glass can be seen clearly. An opaque material, on the other hand, absorbs or reflects all the light that strikes it, preventing any from passing through, which is why you cannot see through such materials. Color filters are another aspect of how light and color interact. These filters are made of transparent materials that only allow certain wavelengths of light to pass through while absorbing the others. When white light passes through a color filter, the filter blocks certain wavelengths and only lets through the color of the filter. For instance, a red filter allows red wavelengths to pass through while absorbing most of the others, so objects viewed through a red filter will appear red or darker shades of their original color depending on how much red light they reflect. Color filters are commonly used in photography, theater lighting, and various scientific applications to control and manipulate the colors of light. They can enhance contrast, correct color balance, or create specific effects by selectively filtering out parts of the visible spectrum. The understanding of how visible light interacts with materials to produce color is fundamental in numerous fields, including art, design, and optical engineering. Through this knowledge, we can control and utilize light in ways that enhance our perception and interaction with the world around us.